Hey, Java developers, ever wanted to build a seriously smart application without getting lost in low level AI model APIs? Today, we're doing just that. We're integrating Spring Boot's simplicity with the raw power of Google Cloud's Vertex AI and the Gemini model using the new Spring AI framework. It's clean, it's declarative, and it's the future of AI development on the JVM. Let's dive in. Before you begin, ensure that you enable the Vertex AI API, install the gcloud CLI, set your Google Cloud Project ID, and enable billing for your Google Cloud project. Make sure Vertex AI is enabled under the project. Also ensure you are authenticated through Cloud CLI. Let's start by creating the stub using Spring Initializer. Here, I'm going to name the project chat and set the artifact ID as com.vertex. Select Maven as the build tool and then add the required dependencies. Now we can add the dependencies. So I'm selecting Spring Web, Vertex AI Gemini, and Lombok dependencies to reduce boilerplate code. And then click on Generate. It will create the stub. This is our chat application. In this project, we have controller, service, DTO, and config packages. We also have an application.properties file where we need to configure the cloud project details. Let's walk through the Maven dependencies. Here, we've defined Spring Web, Vertex AI, and Lombok dependencies, and we've also added validation to handle request validation. Here, I've created two simple record classes, chat request and chat response. Chat request takes the user's input prompt and chat response sends back the model name, the original prompt, and the AI's reply. Now let's look at the heart of our application, the chat service class. This is where Spring AI connects with Google's Vertex AI Gemini model. I've injected a chat client from Spring AI, which handles all the heavy lifting of talking to the Gemini API. Inside the method chatons, I'm using a prompt template to structure the conversation. It adds a small system note for context, like setting the AI's behavior, and then inserts the user's actual prompt. Finally, the chat.prompt.call content line sends the request to Gemini and returns the AI's reply as a simple string. There's also a helper method called model name. It just returns the model we're using, in this case, Vertex Gemini. So in short, this service acts as the bridge between your React front end and the Gemini model, keeping the logic clean, simple, and reusable. Now that our chat service is ready, let's wire it up with a REST controller. This class is called Chat Controller and it's responsible for exposing our chatbot API endpoint. It's annotated with at REST controller and mapped to /API/chat. Inside, we inject the chat service which we just created earlier. The key method here is chat. It handles post requests coming from the React front end. Those messages the user types in the chat box. We take the request body as a chat request object validated with @valid. Then we call chatservice.chatons with a system note, in this case, answer clearly. The AI's reply from Vertex Gemini is wrapped in a chat response object, which includes the model name, the original prompt, and the generated reply. In short, this controller is the bridge between the front end and the AI engine. It receives the user's prompt, sends it to Gemini, and delivers the answer back to React. Clean and simple. In this part, we are configuring cures for our chat application. We do create a course config class annotated with @configuration to make it a Spring configuration class. Inside, we define a course configuration source bean. Here, we specify the allowed origins, in this case, localhost URL, which is useful during local development. We also define the allowed HTTP methods get, post, and options, and allow all headers with asterisk. Finally, we enable credentials so cookies and authentication headers can be sent. This configuration is registered for all endpoints with slash asterisk asterisk, ensuring that our front end can communicate smoothly with the backend without coarse issues. Alright, now let's take a look at our application configuration. These properties in the application.properties file tell Spring AI how to connect to Google's Vertex AI Gemini model. We start by naming the app spring.application.name equals sign chat. Then we provide our Google Cloud project ID, the region, and the Gemini model we want to use. Here, it's Gemini-2.0- flash dash light comma, a lightweight and fast model version. Next, we fine-tune the model's behavior using a few parameters. Temperature equal sign 0.3 keeps the responses focused and deterministic. Top k equal sign 32 and top p equal sign 0.9 control how diverse or creative the output can be. And max output tokens equal sign 1024 limits the length of the reply. These settings together help balance creativity and clarity, so your chatbot gives meaningful, concise answers every time. Let's run the Java application first. We will clean and then install the application. Let's wait for the application up and running. There is no build error. We can run the main class. Now we can test the chat tool in Postman or command prompt read, trying in Postman. Also, we can test the chat tool in command prompt using curl command. Now let's check out the React front end. This is the main app.tsx file that powers the chat UI. I'm using React hooks like useState and useEffect to manage the chat state, track messages, and handle scrolling automatically. Whenever the user types a message and presses enter, the send function is triggered. It adds the user's message to the screen, then calls the backend once using send once, which talks to our Spring Boot API. The response from Gemini is added back as an assisted message, creating that chat-like experience. I've also included a simple loading animation with 3 dots while waiting for a reply. And finally, at the bottom, there's a small status line showing the connection URL. By default, it's localhost 8080, where our Spring Boot backend runs. So this React component handles everything: message state, rendering, and connecting to the AI backend, all in a clean, minimal design. Let's run the front end and run the application. Type npm run dev now. The application is up under localhost 5173. Let's test the application. I'm typing hi. Yes, it is given the response. How can I help you today? Now let's try what are the planets in solar system, okay? Great, it listed out all the planets. One more try, what's the capital of India? So we today learn how we can integrate Spring AI with Google Cloud and React JS application. That's it for today's walkthrough. I hope you found it helpful and got a clear idea of how everything comes together. Don't forget to like, subscribe, and hit the bell icon so you won't miss our future tutorials. Thanks for watching, and I'll see you in the next one.